4.1. How many monthly deposits of $600 are needed to accumulate 12 grand in order to an account that pays 5.7% interest compounded monthly? So again, we have monthly, and they match, and we're happy because there's less work to do. And then we're accumulating 12,000, so that means that goes at the end. And then monthly to payments of 600. So we're going to say we make the first payment now. Next payment, one payment later, because we're not specified here. And we're trying to make 6 payments. And then our R is 0.057. It's monthly, so that means I is 0.057 over 12. SN would be that 12,000. And the regularly scheduled payment, big R, is your 600. So this is everything we need. And we're just going to plug it in. So we get 12,000 equals 600 times 1 plus 0.057 over 12 to the n minus 1 over 0.057 over 12. The reason that this looks different than one we did before is because this one is an S sub n problem. So this is using the S sub n formula from the formula sheet from chapter 6. First step is I'm going to cross out the zeros to make life easier. So we're left with the big fraction. Now we're going to multiply by our I to get it over, to get rid of the fraction. So 120 divided by 6 is 20. We're left with the numerator over here. Move the 1 over because we want to get the thing that's to the exponent alone. And then we're going to take the natural log of each side. Again, the side, not the number, just the side. We're going to pull this power down. So we get the natural log of 20 times 0.057 over 12 plus 1 is equal to n times the natural log of 1 plus 0.057 over 12. And then we divide by the natural log of this number. So then n is the natural log of 20 times 0.057 over 12 plus 1 divided by 1 plus 0.057 over 12. So that means that n is equal to, pulling out our calculator here, .057 over 12 plus 1. You can use a second set of parentheses in there. You don't have to. You have to make sure that you end the parenthesis in the right spot and divide before you do the next natural log. So if you miss that parenthesis, it will throw off your answer. So here we get 19.15. So it would be 19 full payments of $300. You don't have to put the payment number, but I think it's helpful. Of $300 and one smaller payment. Okay. Now number 3 you're going to do on your own, and we're going to go ahead and jump to the second part of this problem, number 5a. Okay, so we're doing number 5 based off of problem number 2. First thing we're going to do is our timeline. So we had payments of $600, and then we're trying to accumulate 12 grand. So we're trying to find the leftover at the time of that 19th payment, because that's what we found before, is that n was 19. So right here this was 19, and then as a refresher, our I was 0.057 over 12. So the leftover at the time of the 19th payment would be 12,000 minus 600 times 1 plus 0.057 over 12 to the 19 minus 1 over 0.057 over 12. And when we plug that in our calculator, $99.28, which would make your balloon payment the $699.28. Sorry about that. Okay, so that would be your balloon payment. So that would be the 19th payment if we made it bigger. So now if we go 1 month later, it's going to change what happens. But again, this $12,000 doesn't have that 1 plus I stuff. So I'm just going to make a note up here. It doesn't have the 1 plus I to the end because we are accumulating it. It is already at the end. Okay, so again, it has to do with the focal date. It has to do with the focal date, so it's just a variation of the formula. Alright, so when we do 1 month after the next full payment, again, we're not going to have the 1 plus I part with our $12,000 because we're trying to get that at the end. So you can almost kind of think about it as a separate timeline. Your 19th payment is $600. You're trying to find this X, but again, we're still trying to accumulate that 12 grand. So it's not going to have that extra piece because again, that 12,000 is already at the end. Okay, so the leftovers 1 month after the time, or sorry, after the 19th payment. Again, is going to have that SN due with this part, but again, that 12,000 is going to stay the same. It's a little different, and this is a type kind of an unusual problem, so you're not likely to see this. The ones you'll see are more like number 4, A and B. So again, I'm just plugging in my formula. And then when you plug that in, it's going to be smaller than this payment because we're making that money, right? Because here we're accumulating, so the interest is doing the work for us. And when you plug it in your calculator, you should get $42.75. $42.75. If you need calculator help, please email me.